Now previously we've looked at how to work out the area of a circle or a part of a circle. This time we're going to have a look at calculating the area of a sector. Now a sector is basically like a piece of pie, I guess would be the best analogy. It's a portion of a circle or a part of a circle. So if you imagine a pizza maybe cut into slices, a piece of that would be a sector. Okay, it's the piece of a circle. We have an angle inside our sector. So at the center of our sector, we'll always be given an angle, or in this case, we don't know what it is. So we're just going to call this theta. And this would be the angle that creates our sector, and it's measured in degrees. Now that's really important because we've got a little formula here to work out the area of a sector, and it is this. Whatever this angle is, divide it by 360, so I get theta over 360. Then simply multiply it by our normal formula. I'm saving words there. Our normal formula for the area of a circle. So in other words, angle divided by 360 divided by the area of a full circle. And I'll just take you through an example and show you why that works. If I've got a full circle here and I only want the area of half of it, we looked in a previous lesson at saying, well, I could work out the area of the full circle and then just halve that. So that would be something like this. Area equals half times pi r squared. Now, this angle in here is 180 degrees. So according to this formula, I could say that the area equals theta over 360, so my degrees over 360. Now I've got 180 degrees, so 180 divided by 360, which if you simplify that gives you a half. So we end up with the same formula as we had up here. In other words, 18 divided by 360 is the same thing as saying half times the circle. Look at another example. This time we'll go with less than half. Let's go with, well, let's break our circle into 8 pieces, and they all end up to be 45 degrees each. And we know that because if I add up all the angles in a circle, they equal 360. Now in this case, I've got 8 even pieces. 8 times 45 gives me 360. I want to calculate just the area of one piece of this pie. In other words, one sector with a 45 degree angle. Using my previous knowledge, I could say, all right, well, I'm breaking the circle into eighths. So my area equals 1/8 of the area. In other words, 1/8 times pi r squared. If I use this little formula up here that we're learning this lesson, I could get the same result. In other words, 45 over 360 is the same thing as 1/8. So these two things are the same. My angle over 360 times the area is the same thing as 1/8 of my circle. So this little formula works for us fine to work out the area of a sector. So let's go through and do an actual example. Okay, I've got a sector here that has an angle of 120 degrees and a radius of 3 meters. My theta, in other words, my angle is 120. My radius is 3. Let's plug those values into my formula and I get 120 over 360 times pi times the radius squared. If I put that all into a calculator, I end up with an area of 9.42. Okay, with this one, I've got this weird and wonderful shape, and we're asked to find the area of the space inside this shape. This is going to be a composite shape question. We're going to split it into a couple of pieces that we can work with. I'm going to split it right there, so now I've got section 1, which is a rectangle, and section 2, which is this really odd shape, but we have a strategy for that. I'll show you in a moment. Section 1 is easy. It's the area of a rectangle, so I use length times breadth to get a value of 96 degrees. Piece 2, however, is a really odd shape. Here are some clues though. I know that these lengths are 8 centimeters because they've got the notch mark here, the congruence mark that shows me they're the same length as that. So I can use those clues to say the area of section 2 would be the area of this entire rectangle here, right, so, or square, I beg your pardon, 8 times 8, take away the area of the bit that's cut out, like a bite, I suppose. So it's going to be 8 times 8 minus the cutout. Now the area of the cutout I can work out using my formula up here. For a sector, I can work out the area of the bit that was taken away. It's a 90-degree angle, so I'm going to apply my theta as 90 degrees and say the area equals 90 divided by 360 times pi times the radius squared, and the radius is 8. The cutout bit, or the bit that's been bitten off or cut off, is 50.24. So the area of this section, section 2, is the entire square, 8 times 8, minus that cut off bit. So I get 64 minus 50.24 means the area of section 2 is 13.76. Add that to section 1, add them both together, I get 96 plus 13.76. Gives me a total area of 109.76 square centimeters. That's a bit of a tricky one, but as you can see, once we can start to use or get familiar with the area of sectors and circles, we can start to solve difficult questions even like this one.